In this video, we're going to discuss how to determine the phase difference between two identical waves. And you can find the phase difference between two identical waves that have the same amplitude and same period or frequency by looking at a displacement time graph of the two waves, like the picture that is shown here. And we can do the calculation for the phase difference by using this little conversion factor, where we have delta t is time divided by the period times 2 pi will give me my phase difference in radians, or I can do delta t over period times 360 and get my phase difference in degrees. So to do that, I find it helpful to kind of go through this little process. So draw vertical lines through adjacent shifted crests. So I'm going to I could draw a vertical line here, and then I could draw a vertical line here, but those are a little bit kind of squished because it's on the y-axis here. So maybe instead I would do this one and then this one. So two adjacent crests draw vertical lines. So delta t is going to be the time difference between those vertical lines. And I can read the time difference off the x-axis because on a displacement time graph, the x-axis is in time. So I can just read the difference between those. And then t is the period of either wave, and I say either wave because they have to have the same period if I'm finding the phase difference between them. So I'm going to maybe pick this wave, and I can see that the period here would be 5. So let's use this relationship to find the phase difference between these two waves in radians. So let's talk through it. Difference in time. So if I go from 5 to roughly, it looks like 6.2, but really it's supposed to be 6.25. So 5 to 6.25 is going to be a time difference of 1.25. And we already said that the period was 5. We read that off this wave here. And then I multiply by 2 pi. And when I do that, so 1.25 times 2 gives me 2.5 over 5. So I could say that the phase difference is pi over 2 radians. That would be reporting my answer in terms of pi. It's also, I suppose, appropriate to multiply that out, and then I would get 1.57 radians. And now let's do the same thing in degrees. So when we do it in degrees, we have still a time difference of 1.25. That's the time difference between these vertical lines. And we divide by the period 5 times 360, and we get 90 degrees. So as you know, 90 degrees is also equal to pi over 2 radians. So it's doing the same thing, just in different units.